Okay, hello grade 8. This is question 8 from the June 2019 exam that you're doing for your homework. I want to talk about this question because this question is all about the exponent laws versus like terms. Okay, so when we see variables, we know that we have to do something with the variables. We have to follow the maths rules. So which rule do we follow? We follow exponent laws if we see multiply, and we follow like terms if we see plus or minus. Okay, so remember the other way of showing exponent laws is with the brackets. Remember, if I've got brackets touching each other, that is also invisible maths for multiplication. So if we have a look here, if we have a look at 8.1, what do we see in 8.1? We see multiplication. Can you see multiplication? So here we have to follow exponent laws. So all of these have an invisible exponent of 1. And if you remember your exponent laws, if the bases are the same and you are multiplying, you add the exponents. So c times c times c gives you c to the power of 3. Okay. Now, if we have a look at 8.2, do you see multiply in here? I do not see multiply in here. I see subtract, add, subtract. Okay. So if we see subtract, add, and subtract, we are doing like terms. So 5x minus 7 plus 3x minus 2. Remember, whenever we do question with variables, we should always write out the expression or the equation exactly as it appears first. Now, this is like terms because these are the same variable and the same power, and they are adding. So we want to put the like terms together. So we put the 5x and the 3x together. Remember, when we move the terms, we must take the sign, the coefficient, which is the number, and the variable. So I've put my x's together. And now I am going to put my constants together because these are constants. They only have a number. And remember, I must take the sign with them. So this is subtract 7 or negative 7. I move it over here. So now I've got 5x plus 3x. That gives me 8x. Negative 7 subtract 2. Remember your integer rules. This becomes negative 9. So these are exponent laws versus like terms. If I have a look at number 3, 8.3, do you see multiplication in here? I do not see multiplication in here, so these are like terms. So if we look at 8.3, then we have, remember, copy out the expression first, 3 minus 4x plus 5x squared minus 6 plus 7x minus 8x squared. Now, if you have a look at this, if we want like terms have the same variable and the same power. Okay, you can see here there are x's in here and there are x squared. So x is the variable, the power on this one is squared, the power on this one is to the power 1. So what you have to realize is that which ones are like terms. So this x squared and this x squared belong together. So we pick up the sign, the coefficient, and the variable. That's 5x squared. And here is the other like term for x squared. It is the sign, the coefficient, and the variable. So I've dealt with my x squareds. Now let me look at my x's, because that is the next highest power. Remember, in algebra, you always do in descending powers of x. And I've got the sign, the coefficient, and the variable. And then I'm going to add this 7x over here. And now I'm left with my constants. Here's a 3 in the front. So it is a plus 3 because there's an invisible plus in front of it. And then subtract 6. Now I have done what is called grouping my like terms. So I've got 5x squared, subtract 8x squared. So plus 5 minus 8 is negative 3x squared. Minus 4x plus 7x, that gives me plus 3x. Plus 3 minus 6 gives you negative 3. Now if we look at 8.4, have a look here. it almost looks like terms, okay? 6a squared minus 3a squared. So it's very tempting to solve this 6a squared minus 3a squared as like terms. But look what's going on here. Here is a bracket, and it is touching the term. This means that we have to do the distributive property. This number outside the bracket is multiplying everything inside the bracket. So this is like a bridge between like terms and exponent laws, okay? So if we have a look here, let's do this one in another color because it's an interesting one, okay? If we look at 8.4, remember we always start out by writing the expression 6a squared minus 3a squared bracket 2a minus 1. So your job is always to realize that if a number or a variable is touching a bracket, we must follow the distributive property where everything outside the bracket multiplies everything inside the bracket, and we must pay attention always to the sign, the coefficient, and the variable. So this is 6a squared, and then it's minus 3a squared multiplied by 2a. So that is my first part of the distributive property here. And then the second part of the distributive property, the sign, the coefficient, and the variable, it's minus 3a squared times negative 1. So 6a squared is a term by itself. If I look at this one here, minus 3a squared times 2a, minus 3 times 2 is minus 6. A squared times a, remember there's an invisible 1 over there. This becomes a cubed, because if the bases are the same and you are multiplying, you add the exponents. And now if we look at this last one, minus 3a squared times negative 1, negative 3 times negative 1 becomes positive 3a squared. And then we could think, oh, look, I'm finished. However, we are not finished. We still have now, look, a minus and a plus, and I have a variable with the same power. So I have like terms again. Now that I've done the distributive property, I've got like terms again. So I've got 6a squared plus 3a squared giving me 9a squared minus 6a cubed. And if you write this in the polite maths way, you put the highest power first, negative 6a cubed plus 9a squared. But these two are basically the same. I would accept either as an answer. Now, let's have a look at this last one over here. Okay, have a look at this last one here. Can you see there is multiplication? If there's multiplication, we are going to use exponent laws. So it belongs under the exponent law column. Let's see if I can sneak it in here, but it's a bit of a big sum. Okay, so because of space, I'm not going to write out the whole sum exactly like it is. We're going to work underneath it, but best maths manners, write out the whole expression first. So what I want to do here is, if you've got this multiplication like this, we can actually work everything on the top as a multiplication sum. So that's what I want to do. Everything on the top is a multiplication sum and everything on the bottom is a multiplication sum. So first I'm going to do the numbers. Negative 3 times 8 is negative 24. Y to the power of 7 times y to the power of 2. Remember exponent laws, the base is y, and we are multiplying. We're going to add the powers. So y to the 7 times y to the 2 gives you 7 plus 2 is 9. And then the x has got nothing with it, so we just write x to the 6 over there. Now we do the multiplication on the bottom. The 4, there's an invisible 1 over here, so 4 times 1 is 4. Y cubed x to the 5. Y cubed x to the 5. Now, can you see here? I have simplified this fraction one step. My next step now is to say, okay, let's look at the numbers. So remember that this fraction line is also the same as division. So I could say, what is negative 24 divided by 4? Negative 24 divided by 4 is negative 6. Then I've got y to the power of 9 divided by y to the power of 3. And I've got x to the power of 6 divided by x to the power of 5. So remember that if you are dividing dividing variables with the same base, okay, and the base is the variable here, y. This is y to the power of 9 divided by y to the power of 3, so the bases are the same. We subtract the exponents, so it's negative 6, and 9 minus 3 is 6, so it's y to the power of 6, and then x to the power of 6 divided by x to the power of 5. So the bases are the same, it's x. We subtract the exponent, 6 minus 5 is 1. So it's like that, x to the power of 1. But we don't normally write it like this. We normally write it in alphabetical order. So it's negative 6x y to the power of 6. And there we go. We've done all of number 8.